Good morning, everybody. We're going to give this a shot. I've never taught a lesson with a video and then posted it, but I'm going to give it a shot. Sorry that I'm not in there. I'm in the dark here, but I wanted you to see the pictures, and you all know what my smiling face looks like. And, well, maybe you don't, because we've had to wear the mask and everything, so maybe at the end of the class we'll turn the lights on, let you see. But I'm going to use the class time that we had allotted. In other words, with 5 minutes to go, I'll shut it down. That way I can get ready for the next video, because I'm going to make one for the honors kids too. So college prep, here we go. I'm going to get out of the way here and do a quick review for you. I'm going to move the chair a little bit here. The pictures are tough because of the reflection of the screen. I'm hoping the text will be better. Quick review: blast cells, fibroblasts. Remember, blast build, clasts destroy. So fibroblasts are building fibrous tissue that you see here. Whatever's in front of the word blast or clast tells you what's being made or broken down. In this case, fib, add the R, add the O. That means fibrous type tissue. Blast means being created. Macrophage, remember phage means to eat. Macro is large. So these are large cells that are eating or engulfing items that have no use in the human body. Mast cells, those are really cool. Notice it looks like the sun with the solar flares. Again, these are just cells that aid in immunity. And then connective tissue fibers, strong bundles of collagenous fibers, which are white fibers made of the protein collagen. These add strength for holding body parts together. If you'll remember, we described collagen as slightly flexible but resists stretching. The exact opposite will be elastic fibers, which are yellow fibers, made of the protein elastin. These are stretchy and add flexibility to certain types of connective tissue. Then the third type is reticular fibers. These are thin collagenous fibers that form supportive networks in a variety of tissues. So the difference between reticular and collagenous is the collagen fibers are thicker than reticular. Elastic is even thinner than reticular. Elastic looks like hairs or string. Collagen thick, it would resemble yarn. Reticular branches out and kind of looks like tree branches, and we'll see some in the other book. They had pictures of it with white blood cells also in the slide. And then number 6, classified as connective tissue proper. That would be the loose and the dense, and then specialized connective tissue. Categories of connective tissue: we have loose connective tissue, including areolar, adipose, and reticular. So areolar is the one that we saw, the very loose fibers. You'll see the thin, elastic, and thick collagen fibers. Adipose is the fat tissue, looks like water-filled baggies. And then reticular, again, looks like tree branches. Areolar forms thin, delicate, membranes throughout the body that bind or connect. Remember, connective tissue connects. Binds body parts together, such as the skin and underlying organs. And they could have put also in there, binds the skin to underlying tissue. The majority of the cells are fibroblasts. Remember, fibro means fibers, blast means to build, create, or make. So these fibroblasts are making the fibrous tissue. That is then separated by a gel-like ground substance that contains collagenous and elastic fibers. The reason being is the characteristics of that tissue then will be slightly flexible and a little stretchy. This is what areolar tissue looks like. If anyone was able to look at the slide, it's a really good slide, should look like that. Notice you see the thin hairs, the strings, that would be the elastic fibers, and then you see the thicker pinkish fibers in the back, that would be collagen. And then what looks like nucleus or nuclei scattered everywhere, those are actually the fibroblast cells making that fibrous tissue. If you look over here in the artist rendition picture, you'll see the fibroblast, and like we saw in that slide earlier, the fibrous tissue coming out of that cell that then creates this fibrous network of tissue that you see here. So that's a really good slide. Hopefully we'll find a way that either you can be here to see the slide, or there's a way that if my webcam comes in and is good, that I can actually view it in the microscope for you, post it with the webcam that you can check it out, and it would be cool. Adipose tissue is loose connective tissue designed to store fat. Remember, that sounds bad sometimes, storing fat, so let's change it to store energy. That makes me feel a lot better when I step on the scale to see how much stored energy I have, instead of calling it storing fat. It's found beneath the skin, around the joints, padding the kidneys and other internal organs, and in certain abdominal membranes. The functions that you'll see here on number 3, and it'll make sense why it talks about around joints, padding the kidneys and other internal organs. The cells that make up fat tissue is called adipocytes. Addi, add the P, add the O, that means fat. Cells, site, so you put the prefix and the root word together, you have fat cells. So 3, the functions: stores energy for the body, also as an insulator, it protects and it cushions the internal organs. Also, as an insulator, it aids in helping us maintain our internal body temperature, homeostasis. This is what it looks like. The cells themselves do not stain very well. What stains is the cell membranes and the nuclei. Speaking of the nuclei, notice I have written here for you, eccentric. The nuclei are eccentric, which means they're not in the center. Remember, we're trained that most of the cells we see, the nucleus is in the center. Here, notice they're at the peripheral, at the edges, and then the cells themselves do not stain. So this is white or yellow fat tissue. There's another fat tissue that is brown. The difference is not only the colors, but the locations, and the nucleus for the brown fat cells is actually in the middle of each cell. The reticular connective tissue is composed of thin collagenous fibers in a 3D network. It helps to provide framework for certain internal organs such as the liver and spleen. It actually covers both of those and acts as another layer of protection, aiding and holding all that tissue together nice and snug. Dense connective tissue, opposite of loose. So for loose, the tissue would look like a handful of toothpicks that you had dropped on the table and the fibers scatter everywhere. Here, dense would be, instead of dropping the toothpicks, you would be holding them in your hand. Open your hand and look. They're all tightly packed and stacked on one another. That's what dense connective tissue looks like, although it can have kind of a wavy pattern to it. The tissue consists of densely packed collagenous fibers and is very strong, but lacks a good blood supply. Remember, collagen, a little bit flexible, but is tough, so that's why this tissue is strong. It is found as part of tendons, which connects bone to muscle or muscle to bone, and also ligaments, connects bone to bone, and the white layer of the eyeball called the sclera. And again, that's what this tissue looks like. Notice that there's very little matrix or the white space that you're seeing here. A lot of crammed in there, packed in tissue, and it does seem like it has a wavy-like pattern. Again, what we think is a nucleus is not a nucleus. It's actually the fibroblast. Fibroblasts are making that fibrous tissue that you see here. That's a really good slide. We have slides that look just like that. Cartilage, a rigid connective tissue that provides a supportive framework for various structures. It lacks a vascular system, so it is avascular, and it heals slowly. This is the difference between cartilage and bone. Bone has a vascular system. It has blood vessels in it, so it heals quickly or more quickly than cartilage due to the nutrients and having a direct blood supply. Cartilage does not. So it can heal on its own, but it takes a very, very long time. We tend not to wait that long and just go the surgery route to fix the torn cartilage. Cartilage cells, chondrocytes, you know from the vocabulary, con, add the D, add the R, add the O, any of those means cartilage, cytes, cells, so put it together, cartilage cells are chondrocytes. And they lie in a lacunae, in a gel-like fluid matrix. Basically what they're saying here is cartilage cells are found in a little pocket. The pocket is called a lacunae, and then you're going to see another covering that they're going to talk about in C, because cartilaginous structures are enclosed in a connective tissue called the perichondrium, which is vascular. Peri, which you're not there yet, but we have another page or two in your vocabulary. Peri means a covering, to surround, to engulf. You know that con, add the D, add the R, means cartilage. So this means that it is covering the cartilage. It is vascular. So this is how cartilage actually gets the nutrients. Even though it doesn't have blood vessels actually in cartilage cells, because of the perichondrium having a vascular system, blood vessels, cartilage is close enough by diffusion that it can get nutrients from the perichondrium and the blood vessels. If you take a look at this right here, this is what I have here. I'm going to move this just a little bit so you can see it. If you take a look at the picture that I've got drawn here for you, this would be the cartilage cell here. That would be the nucleus. Then you have the surrounding here. You've got this white space in here. That would be the matrix, and that would be the lacunae, that gel-like substance that you see here. And then notice that I put red out here. The reason I put red out here is the red would then be the perichondrium. So that's where the blood vessels would be here. Doesn't penetrate and go to the cartilage. However, because remember, this is microscopic, so this is extremely small. So these are so close to one another that by diffusion, nutrients here will diffuse here into the actual cartilage cell itself. There are three types of cartilage, and the first one is the most common, which is hyaline cartilage. It's white with abundant fine collagen fibers found at the ends of bones and supports the respiratory structures and passages. Also important in embryonic development of bone and bone growth. As we are an embryo and developing to eventually become us, your skeleton is comprised mostly of cartilage. Some of that cartilage will go through a process called ossification, which means turn to bone. The rest of it will remain cartilage. And as you can see here, this would be like the cartilage you find in your rib cage that has a specific name called the costal cartilage that you find. And this attaches your ribs to the front of the body and the sternum and allows flexibility as we breathe in and breathe out. This is a really good slide. Now the key here is, notice they said with abundant fine collagen fibers. There are so many and they are distributed so evenly that it's really hard to see the collagen fibers. If you take a look over here to the right hand corner, the upper corner here, you can kind of see some of that collagen fibrous tissue here, but notice it's kind of pink here. And again, it's just distributed so evenly through there, it's really hard to see, but it is in there. This is a good slide. Notice again that you'll see the nucleus and the cartilage cell stains a little bit. The nucleus, more than anything, stains really well. Then the lacunae, the gel-like substance that's around the cartilage cell, doesn't stain very much. And then the edges where you see the perichondrium, and notice that I circled one in red for you, and then I wrote perichondrium at the bottom. So when you see that darkish area on the outside, that's representing the perichondrium. So you can see that in this little bundle here. So that dark ring around each one of those separate ones, perichondrium, you can really see it on these ones on the right-hand side. It's really, really dark. But that's what separates it, helps separate the individual cartilage cells that you can see. That's a really good slide. Ours looks like that. Now notice the number of cells, notice the number of cartilage cells compared to the collagen fibers. You see a lot of hyaline cartilage cells, but you don't see a whole lot of collagen fibers. And again, the reason being is because they're so abundant, so evenly distributed, they're hard to see. Where elastic cartilage has elastic fibers, provides a framework for the external ears and parts of the larynx, your vocal cords. What this does, and you can take your ears forward and let go, it allows the body part to snap back. Our vocal cords, it allows us to yell and raise our voice. It gives it strength. Notice you do see a lot of the elastic fibers. So it's a little different than the other one because you do get to see a lot of the elastic fibers here. Now again, right here, if you take a look, there's the cartilage cell itself, the nucleus I've colored green, then I made the cartilage cell itself as blue, then you have the pocket, the lacunae on the outside, and then in red, the outer portion, which is the perichondrium. They don't label it, but I colored it for you in red. But that's the dark area around each one of these things, each one of these elastic cartilage cells. That would be the perichondrium. Again, good slide. And then fibrocartilage. Remember, F-I-B, add the R, add the O, that is fibrous. So you know this is fibrous cartilage. And here it explains it with many collagenous fibers, is a tough tissue that provides a shock-absorbing function in intervertebral discs and in the knees and pelvic girdle. Now with this one, notice that you actually do see it. What you see is pinkish purple, those little lines. Looks like someone took a pinkish purple pencil and kind of colored in and shaded in between the cells. Those are the collagenous fibers that make this tough. This is for shock absorbing. So notice here it's talking about your intervertebral discs. Here the picture, the discs in between the vertebrae in your back. A lot of weight bearing there. Also notice it says the knees. So this is kind of a weight bearing, shock absorbing type of cartilage. Again, the collagen fibers are here. And then there's the cartilage cell. The dark area on the outside is the perichondrium. The area that you see inside there then is the lacunae, the cartilage cells in there, and then the nucleus is colored and stains the most of all of the cell parts. All of those slides are pretty good slides. We have slides that look like those. And then bone tissue is the most rigid connective tissue. It's actually the most rigid tissue in the body. It has deposits of calcium, mineral salts, phosphorus, we'll talk about that when we get into the skeletal system, and collagen within the matrix. So the material around the cells has calcium, mineral salts, and collagen around it. Bone internally supports the body, protects, forms muscle attachment, and is the site for blood cell formation. Again, before I took any anatomy classes, I assumed that the cardiovascular system that has the heart and the blood is part of it, I thought that is the system that made our blood cells, but it's actually the bone. And again, it's a really cool system, and we'll talk about that when we get into the skeletal system. Bone cells are called osteocytes. Not quite there yet in the vocabulary, another page or two, but osteo, O-S-T-E, and then adio, osteo, it means bone. And you already know cytes means cells. So if you put it together, it's bone cells. Lie within a lacunae, similar to cartilage, and are arranged in concentric circles. These circles are called osteons around a central or haversian canal interconnected by the canaliculi. Now what they're talking about here is this, and I'll show it to you when the slide for the bone tissue pops up. You'll see what's a black dot in the middle. That's called the central canal, which is also known as the haversian canal. And then it's like a hurricane. It's like circles around that dot. The haversian canal, central canal, would act as the eye of the hurricane. And then you would draw the bone cells, the osteocytes, around in a circular pattern. And those were called concentric circles or osteons. And then the bone cells themselves are interconnected by canaliculi. And if you look at the first part of the word canaliculi, it spells canals. So these are little canals connecting the osteocytes together. Bone does have a good blood supply, so it enables rapid recovery after injury. And when we get to the skeletal system, I'll talk specifically about how bone repairs itself. This is the slide I want you to see when looking at bone tissue. I want you to look at ground bone. So I have two different types of bone slides. You can look at the other one. Feel free to look at the other one. But the one I want you to see and draw is this one. This is ground bone. Notice here, the black dot, that would be the eye of the hurricane. That is the central canal, also known as the haversian canal. And then notice, you see, and I have them shaded in green. Not sure how well the video can show you the green. But if you see, these are, I shaded them in green a little bit. All of these that look like a nucleus scattered everywhere, that is the actual bone cell in the lacunae. It's hard to see the actual bone cell itself. Notice here they have it super magnified that you can see it down here. And it kind of looks like a bean with a bunch of legs. Those legs are the cellular processes. And then you'll see these little dark lines that kind of look like veins here. Those are the canaliculi that are connecting this bone cell to another one that's over here. So this would be the lacunae, which the bone cell it's actually found in. This is the central canal or the haversian canal. And then notice they look like it's made in a circle, a circular shape. This would be considered the osteon here. Here's one, there's actually part of one here, here's one, and then here to here. So I used a bracket, I drew brackets on there for you to show you where the osteon is. And then blood is also connective tissue, which makes sense since it's made by connective tissue, which is bone. Blood is composed of formed elements suspended in a liquid matrix called plasma. The formed elements include the red blood cells, which we can call RBCs, to carry oxygen. Hemoglobin is the actual part of the blood cell that carries oxygen. White blood cells, which we can call WBCs, we know white blood cells are for protection, aiding in immunity. And then platelets for blood clotting. And we've talked several times about how blood functions to transport substances throughout the body. Extremely important in transport. Not only oxygen, but the blood cells themselves, oxygenated, deoxygenated, hormones transported through the body in the blood. Now, our slides will look similar to this. The problem with our slides compared to this one is that this is extremely magnified compared to what ours will look like. Ours won't look quite that big. You'll be able to see what you see here. They just won't be that big. The red blood cells are easy to see. They do not have a nucleus. Red blood cells do not have a nuclei, so that's why you kind of see that little white space in the middle there. Platelets will be little chunks. You'll see little purple chunks or dark chunks. Those would be platelets. Now, you might not find a lot of platelets in your blood tissue because remember, it aids in clotting. So if there's no reason to clot, you may not see a lot of platelets in your slide. But you will see some white blood cells, maybe one, maybe two, because unless you're sick, you don't need a lot of white blood cells out there. But they will look really deep, dark, and purple like this. So this is a really good slide, just super magnified of what you will see. We'll see everything you see here. It just might not be so big. And then on page 120 in the book, this is a really nice chart summarizing everything that we've just looked at in connective tissue. Notice you have the types to the left, the loose connective tissue, the three types, areolar, adipose, reticular connective tissue, and then the dense connective tissue, specialized connective tissue such as hyaline cartilage, elastic cartilage, fibrocartilage, bone, and the last one we just looked at, blood. It gives you the function of each, and it will tell you the location where you find each one. And then types of membranes. I'm going to do this one really quick so you can do this and we can add it because it is part of connective tissue. Epithelial membranes, we've talked about those before. Those are thin, sheet-like structures composed of epithelium and connective tissues covering body surfaces and lining the body cavities. The serous membranes are double membranes that line body cavities and are not open to the outside. So this would line the thoracic cavity and the abdominal cavity. It includes the pleura, which you know is around the lungs, pericardium, around the heart, peritoneum would be the abdominal cavity. And remember, going back to chapter 1 here, we're adding to what we've previously learned, and we're actually doing a little review here. The parietal portion lines the cavity wall. The visceral portion covers the organs. Remember, visceral touches the organ, parietal does not. Parietal creates the cavity. And in between the two is a small amount of lubricating serous fluid, because you do not want the two tissues rubbing on each other, which may tear. Mucous membranes lines cavities and tubes that are open to the outside. The reason is that the mucus needs to be there for two reasons. One is that it will act as a lubricant, keep areas of the body moist. Two, it acts as a protectant. Items can get stuck and trapped in the mucus, and then the body can expel them. This includes the oral and nasal cavities, the digestive, respiratory, urinary, and reproductive systems. Remember, we looked at this as epithelial tissue. That's why they're called epithelial membranes. These contain goblet cells. And remember, from looking at our epithelial tissue, goblet cells produce mucus. And then the last one is cutaneous membrane, which is the skin, a dry membrane that is keratinized for protection and waterproofing. Remember, our skin cells are alive at the basement membrane. They are alive at the basal, the bottom layer. They get filled with keratin, the nucleus disintegrates, the cells become dried out and hard because they're filled with keratin going through the keratinization process. They go to the outside, make up the outer portion of the body, the outer skin. They fall off in a process called sloughing off, which sounds gross. And depends on our genetics, within every 5, 7, 10 days, we have a new outer layer protecting our body, a new layer of skin. Connective tissue, the membranes are made entirely of connective tissue. This includes synovial membranes that line certain joint cavities. Those joint cavities are connective tissue. They are synovial joints. That's why I have the word synovial and joint circled, because that is the synovial joint. And then next is muscle tissue, but we're going to stop there because muscle tissue is the next unit. So I want you all to work on your connective tissue study guide. You can do that ID. Use the PowerPoint. Use this video. You can go back. And the best part about video is if you want to see something that I said, you want to see it again, read it again, hear it again, all you have to do is hit pause and back up, or stop and back up to see it again. Well, I'm going to review it and see how it works. Hopefully it did. I wish you all were here. That would make everything a lot easier and better for both of us, but we'll do what we have to do to make it work. And if you have any questions, again, don't hesitate to get a hold of me, email me, call me. Feel free to get a hold of me at any time. For those of you that still need to make up items from being absent, get with me. We can Google Meet and we can make up quizzes and tests, things of that nature. We can make that easy. Hopefully we can get back soon if we have to take a test on chapter 5 for you all, because it will be on the microscope. So I'm hoping that we can come back and do that. Hopefully the webcam that I ordered will be in the next day or two, which I'm really looking forward to. I'm using my phone here, and I noticed there's a little bit of a shadow here. So I hope the video, what you see on the PowerPoint, was still good enough that you could see at home. But I'm hoping the webcam would be really good, that I could use and go in the back and use the microscopes, put the webcam up to the lens and actually see the tissue. If that works, then what I will do for your drawings, because I can't really expect you all to come in here and do that, at the same time I want you to see the slides. What I will probably do, if the webcam will work for me, I will take the webcam, stick it at the microscope, find the tissue, the slides, tell you what you're looking at. I'll do what I did with the paper towels. I can get my own paper and draw it for you and show you what you need to draw, how to draw it. Good, because you get to see it, you get to draw it. Bad, because now everybody's drawings should be the same, because I'm going to basically show you and tell you what you need to draw. So for your class and honors, all drawings will now look the same, which, what are we going to do? Not much we can do. But hopefully y'all are good. Stay safe, stay well. Hope to see you soon. If you need to get a hold of me, you know how. Please do. And until the next video, adios, amigos and senoritas.